from the media on the phone bridge and through social media. But before we get started, let's learn more about this fascinating comet and share some images. Ahmed, kick us off.
Hi, everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025, to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it gets warm.
Bien, pues Bruno, ya estamos en vivo aquí en esta retransmisión de este mensaje de la NASA sobre el 3.1 Atlas, aquí haciendo mil y un malabares con todo y mascota para esta transmisión. Bruno, ¿cómo estás? Bienvenido.
Hola, ¿qué tal Inés? ¿Qué tal Jesús? ¿Cómo están?
Bien, pues Jesús apenas viene ya acomodándose, todavía no trae ni el micro puesto, pero pues apenitas ya está comenzando esta transmisión de la NASA. Vamos a estar buscando por aquí algún link donde venga subtitulado, pero pues si no, vamos a aprovecharte, Bruno, ahí para que nos vayas traduciendo básicamente en vivo. Mira, acá está la Chucha que nos viene a acompañar.
Va a estar muy difícil traducir todo en vivo, pero no soy un experto, pero vamos practicándolo primero.
Y si quieres, ahorita en lo que encuentro una que venga subtitulada.
Sí, mira, ahorita no están hablando respecto a qué es un cometa, básicamente.
Digo, de ahí de inicio, y sé que es mucha la especulación que se ha venido generando en torno a este cometa. Sin embargo, digo, lo lógico sería que nos muestren algunas de las fotos que fueron tomadas, que no han sido reveladas, y lo cual ha generado mucha más especulación al respecto. Sin embargo, pues tampoco veo muy posible que se dé algún anuncio súper escabroso, ¿no? Si fuera el caso, pues yo creo que fuera Donald Trump el que lo fuera a decir, no la NASA. No sé tú cómo lo vas viendo.
No creo que fuera Donald Trump que lo anunciaría, pero a la vez no creo que vayan a decir algo escandaloso. Van a simplemente hablar del cometa y van a tratar de tomarlo desde un punto de vista lo más científico posible. Pero pues ahorita nomás hay una forma de saber. Hay que verlo.
Hay que verlo, ¿no? Y fíjate, creo que una de las cosas que va a llamar bastante la atención, o quizá lo más esperado, va a ser el tema de las anomalías, ya que si bien es cierto, ya hay varias anomalías que se han venido señalando por distintos astrofísicos, pues ya el hecho de tener una postura oficial por parte de una institución como la NASA, pues bien, pudiera venir ya sea a aclarar algunas de estas anomalías, o por el contrario, a aceptar con bastante humildad que efectivamente pues no sabemos al respecto, que no tenemos las capacidades de entender muchos de los fenómenos del cosmos. También algo que me parece prudente recordar, este es el tercer objeto interestelar, apenas el tercer objeto interestelar que se conoce, por lo cual pues me parece bastante lógico que nuestro conocimiento sea sumamente limitado. No sé tú, Tonka, ¿cómo lo ves?
Bueno, en ese sentido, ya habíamos comentado un poco, ¿no? Al respecto de cómo, además de que justamente es algo ya desconocido, pues, o sea, de entrada ya es un fenómeno que no se conocía. Es decir, sí, ya es un fenómeno desconocido. Ahora la otra, pues, es esto que acabas de decir me parece bastante bueno, pues, el hecho de, digamos, como comunidad científica, el aceptar que no hay ahorita un parámetro, no hay formas tal cual con la tecnología que tenemos para decir, ¿sabes qué? Lo podemos analizar de esta manera, o presenta otras anomalías que no habíamos descubierto antes, ¿no? De hecho, incluso yo creo que justamente para los científicos, quienes sean realmente como honestos, como tú dices, o un poco más humildes, o realmente aquellos que sí tienen este espíritu verdadero de la ciencia, de buscar el avance, de buscar lo nuevo, de buscar decir cómo superar las fronteras de lo ya conocido, ¿no? Vaya, ese es el conocimiento tal cual, así es como se forma, y así es como como se ha hecho a través de los años y de la historia. Bueno, digo, yo estoy exagerando, ¿no? Y lo estoy llevando a otros límites, pero creo que desde ahí ya es algo muy importante. Pues más allá de si es algo artificial o es algo
No,
natural,
bueno,
pues,
si
o
llegase a
sea,
ser algo artificial, imagínate, ¿no?
sería
La
todavía
locura total.
muchísimo más, ¿no? Exactamente, eso. Y ahí es donde están, pues justamente esos límites de los que ahorita estábamos comentando. Bueno, no sé si va como pues en ese sentido. Yo también estoy buscando también acá las noticias, pero no tuve ni siquiera
No,
mi
yo creo que
oportunidad
ya
ahorita
encontré,
de acomodarme y demás, pero pues aquí estamos bien también en la misma transmisión y ver
que ya
cómo...
encontré una, nomás que me acabo de dar cuenta que
Sí.
estoy en el equivocado.
Mira nomás.
Mira nomás, aquí ustedes ayúdenme a estirar la línea, a hacer más tiempo en lo que ponemos aquí la otra
Además,
pantallita, ¿eh?
también por ahí, si no me equivoco, tienes abierto algún audio o alguna cosa así.
Sí,
O
ahorita
sea,
los...
esperemos que no se esté como escuchando también en la transmisión, pero pues no hay problema, ¿no? Finalmente, aquí estamos tratando de hacer las cosas como podemos. Y no sé, ¿tú qué opinas, Ian? Bruno, Ian.
¿Qué se espera? No sé
Estoy
qué
ahorita
opinas.
poniendo atención a la transmisión, una disculpa.
Sí, está bien,
Son
adelante.
dos conversaciones que no puedo simultáneamente escuchar.
No, está bien, de hecho eso se trata, pues, igual en ese sentido, ¿qué va pasando? ¿No? Ahí nos dices algún comentario dentro de lo que vayas viendo en la transmisión.
Sí, todavía no empieza como tal, ¿verdad?
Ujú.
No, ya empezó.
Ya
Ya
estamos ahí.
empezó. Ok, pues ni modo, pues vámonos así en inglés. Déjame nomás buscar rápido, sería una...
Yo ya no la encontré por acá, pero bueno, entonces
Sí,
ahorita vamos a...
déjame
em,
aquí está,
yo
esto solo
solo...
acá.
A mí, ay, hey, ¿qué pasó, Shusha?
Ahí
Aquí
está.
está la
Déjame nomás
Shusha,
subirle aquí un
también muy al
poquito.
pendiente de todo.
Because we have many different assets in different
Ay.
locations, observing things in different
Voy a,
wavelengths, in different ways, with
en lo
different
que empezamos a
instruments,
ver un poco
each
acá
set of
la transmisión
observations
y hacer algunos
providing a
comentarios
different
respecto a lo que
lens
se vaya
for
diciendo.
understanding objects in the
Dame
sky.
un momento porque
So NASA's science
Marco
team has
empezó
kept watch of the Eye Atlas for nearly its
Fundamental.
entire journey through the
para la
solar system
transmisión.
for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026.
Entonces ahí vamos
So the NASA
a observar,
assets
¿no?
that are
Que se
gathering
va,
observations
que
of
se va
Three Eye
diciendo, que
Atlas
se va
include Hubble,
también
the James Webb Space Telescope,
desentrañando.
TESS, SWIFT, SphereX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche,
Sí,
Personal
creo que
Favorite,
una de las
Solar
diferencias, por
Probe,
ejemplo, como
Punch,
pasó con el
Stereo, and
MOA,
ESA,
el otro
NASA's
objeto
SOHO mission.
interestelar
And
que
I'll
se
note that Parker
detectó, va a
Solar
ser
Probe's
el
data were
tiempo en
just
el cual se va a
downloaded
poder
yesterday,
estar
and indeed
haciendo
we did catch
análisis.
several
Es
glimpses of this amazing
hasta
comet.
primavera del próximo año
The
donde se va a
scientific
seguir
community
viendo
is hard at
este
work
objeto,
analyzing
lo
these
cual sin
images,
duda
and
pues
everyone, as
ya desde ahí
always,
ya
is
marca un
welcome
hito
to
en la
take a
historia, el
look.
tener la
At NASA, we
posibilidad de
embrace
generar
open science. We
estudios
make
mucho
all of
más
our data
profundos
available
respecto
to
a
the
este
public
tipo de cuerpos
24/7, and we invite, in fact, we really want you to tell us
Sí,
what
o sea,
you're
de que va a tener,
observing and what
digamos,
you
un
think
poco más
about
de
what we're looking at.
proyección, pues,
We're
en ese
still
sentido.
learning even about what
Van a haber
questions
meses,
we
pues,
still
en lo que se
need
puede
to
hacer.
ask.
Y es lo
And
que,
this,
como
of
bien
course, is the
estamos viendo
scientific
en los
process
otros
in action.
videos,
All the
pues,
data
o
go to a
también
public
en las
archive.
otras
We get
noticias,
those
que la
images
diferencia
as
es eso, ¿no?
soon as we're
Cómo
able to
justamente está
from all of
llegando,
our
cómo
eyes in
justamente
space.
está afectando,
As
que
always,
viene
I
en la
am
misma
excited to see
órbita,
what
pues,
new
o en la
things
misma,
we learn
en la
about
misma
our
línea,
friendly
vamos a
solar
decir
system
así,
visitor in the
la
days and,
órbita
in fact, the years to come.
de nuestro sistema
So
solar,
now I'm
pues
going
a
to pass
diferencia de los
over
otros que,
to
digamos, fueron
Sean.
como
He's going to tell you about
perpendiculares, ¿no?
what our
Llegaron en
astrophysics
otras
missions have
maneras.
seen.
Exactamente,
They,
fue
of course,
una de
were some
las
of the first
cuestiones que
things
llamó
to
mucho
look
la
at the comet,
atención, sobre
and
todo
images
desde
from,
la
from several
difusión
of
que
them
le
have been
da
available since the
Avi
beginning of
Loeb,
the summer.
pues ya ahora
So
súper
I'm going to ask you to
famoso
set the stage for us.
astrofísico,
Tell us
es
what you've
justamente
already
la
seen
trayectoria que
before we
trae
hand
este
over to
cometa. Para
Tom to tell us
empezar,
all the
el
new
hecho
stuff.
de que
Take it away, Sean.
básicamente
Thanks,
pues,
Nikki.
pasa
Happy
por
to.
todos los
To give you
planetas.
some
O sea,
background, NASA's
a ver,
astrophysics missions, like all our
ya están
missions,
haciendo otras.
they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like Three Eye Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like Three Eye Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world. including the science community and our partners across the planet that often have ground-based assets or other space-based assets so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. Not too long after that, in July, it looked at 3I Atlas, not long after we discovered it from the ground. At this point, 3I Atlas was about 277 million.
Y que es justamente una de las interrogantes que se ha generado en torno a este cometa, por las reacciones químicas o aparentemente que ha venido teniendo en esto de los cambios de color, en el tema de la condensación, en el tema de la cola.
Importantly, the size of the nucleus.
Quizá, si bien es cierto que ya tenemos una tecnología superior a la que tuvimos en algún tiempo, obviamente aún estamos muy lejos de poder realmente tener certeza, al menos la distancia de la ejecución de estos objetos. Otro de los temas que a mí me brinca sobre las especulaciones que han girado en torno, básicamente que no tenemos suficiente información al respecto para tener algo concluyente. También puede haber alguna falla de mediciones y un largo etcétera. Ojalá que algunas de ellas, de estas anomalías se pudiesen comprobar al momento, que también hay varias que todavía resulta improbable el que haya una explicación como tal, lo cual no es una condición sine qua non para que sea un objeto artificial. Básicamente puede ser un reflejo de todo aquello que nos ha faltado por aprender, ¿no?
Colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that objects are made of. So with these infrared observations with James Webb and Sphere-X, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just to put this in context. There are, every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system, and that's true for this comet as well. So it could mean, in line with the last theory of why those ratios could be different, that these ices could have been exposed to higher levels of radiation than comets in our own system. Or, as I said before, it could be that the comet just formed from a region where carbon dioxide ice was particularly abundant and different from our solar system. Other missions like our SWIFT spacecraft, which studies X-rays and gamma rays, have also observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information is helping us understand the comet's history before it got closer and when those other observatories pointed at it. Now that the comet is near, relatively speaking, our planetary and heliophysics missions have joined into telescope. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
Muy bien, muy bien, muy bien. Bueno, pues es que igual, sí.
Igual quiero ir comentando lo que pongo la...
Pues yo lo que pues estoy observando aquí
In
es que
July,
están dando, digamos,
it looked at 3i Atlas.
Le bajo el volumen aquí porque...
We discovered it from the ground.
explicación general.
At
Pues,
this
o sea, de
point,
los
3i Atlas was about
componentes que tiene. Pues dice también que
277
hay una
million miles from
explicación,
Earth.
digamos,
And what Hubble's images revealed was a few things. First, a
natural, pues,
teardrop-shaped
vamos a decirlo
coma
así, porque,
of
digamos,
dust coming
tiene
off
estas
that
emisiones de dióxido de
solid,
carbono.
icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point, actually, we knew it's between 1,400 feet in diameter up to as large as 3.5 miles in diameter.
La interpretación simultánea, ¿no?
Hubble also saw that the comet was losing dust. Not just losing it, but losing it at a rate consistent with other previous sunbound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. Now, what James Webb did, and its companion Sphere-X, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared observations, with James Webb and Sphere-X, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles you might see in the top right of these images. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just to put this in context. There are, every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system. And that's true for this comet as well. So it could mean, and this is the last theory of why those ratios could be different, that these ices could have been exposed.
Señales tecnológicas de radio. Vamos directamente a escuchar las palabras de la NASA, de los miembros de la NASA.
From the media on the phone bridge and through social media. But before we get started, let's learn more about the fascinating comet and share some images. Amit, kick us off.
Hi, everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025, to the Minor Planet Center. And NASA has been tracking and studying Comet 3i Atlas ever since. We're here today to give you the latest of what we know about Comet 3i Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star, like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet and all evidence points to it being a comet. But this came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars, from our amazing machines that have been roving the planet for 30 years to look for those things.
No, ya va a ser algo popular, como se puede decir de esta manera, ¿no? Y quizás esta parte...
Oigan, ¿sí están escuchando el video?
Tiene problemas técnicos, ¿no? Por ahí.
Pues ahí escuchamos la conexión desde Washington, D.C.
A ver, ¿qué pasó? Es que aquí se nos cortó un poquito.
¿Sí están viendo el video?
No, se nos cortó.
Se cortó.
¿Se cortó el video?
Sí.
Ah, no, me refiero al enlace.
Por eso, el enlace se nos cortó.
¿Sí?
Ahí está. Ya lo puedo poner otra vez, ¿eh?
Muy bien.
¿Qué pasó?
No, es que están ahorita explicando sobre cómo están viendo las fotos de Atlas desde el espacio y cómo se diferencia desde la Tierra, pues, por la luz solar. Eso es algo que están ahorita hablando, que es importante.
Ya lo recuperamos.
In the middle, there's a fainter band indicating it's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from Comet 3I Atlas. It's a little blob rather than a big streak, because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, Maven's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3i-atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. The answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness and an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. It's not, doesn't seem to be a big, at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, some solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means that 3I Atlas is not just a window into another solar system, it's a window into the deep past, and so deep in the past that it predates even the formation of our Earth and our Sun.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Tell me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got to point. It's natural to wonder what it is, and we actually love, as Amit said, we love that the world wondered along with us, and that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, we were very quickly able to look for sort of, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it, but the really cool thing about this is the differences, because it comes from somewhere else, and that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any techno-signatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing as comets do. It evaporates carbon dioxide gas. It evaporates water. But it's evaporating more carbon dioxide compared to water. So that's a very interesting thing. Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to test, and those that are supported by the evidence are the ones that survive.
All right, we'll take our next question on the phone bridge, and that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data, and are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that. Every new object we discover is a new piece in the puzzle. What we're trying to do always is to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question, and we get little bits little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects. The way they are distributed through space in the outer solar system show us clues to how the orbits of the major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system. Or in some cases, we point our telescopes at other debris disks, which is just, a whole system full of these small bodies. And so now what this will let us do is tell that story in a broader context between the detailed and large library of data we have on those origins of our own solar system, and how volatiles were delivered to make life possible here on Earth, combined with that big picture of other systems and the dust spread throughout those other solar systems. And now with this visitor that got frozen in time from somewhere beyond our solar system, and that small picture of what that was like from that point.
And the fact that, I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. It's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition, and that's allowing us to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged to actually be able to unlock the secrets as this cometary object is coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you, obviously we're not going to run it again, but please, go online, take a look at go.nasa.gov/3i-atlas and take a look at the trajectory. I kind of talked through it briefly. Tom talked through it, and you can sort of see where those planets are. And remember this, even though it's exciting and it's coming through, space is huge, as both Sean and Tom talked about. And so the probability of it actually hitting anything is super, super small. You have to have all these things aligned to actually be able to do it. But certainly the objects in our solar system will be just fine.
And we have another question from social media from Astronomeum. They ask, what makes Comet 3i Atlas so different and intriguing compared to the other interstellar comets?
The other interstellar objects, we say interstellar objects because not all of them were comets. So the first one was discovered in 2017. That was 1I Oumuamua that behaved very much like an asteroid. again, a little bit like 3I Atlas, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive, long-duration observations and understand exactly what it was doing. It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second object, 2I Borisov, discovered in 2019, behaved, it was a comet. It was definitely a comet. It behaved in a lot of ways like our homegrown solar system comets, in many ways like 3I Atlas. Its properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3I Atlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data, we are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also to make sure it's usable, so you can get the tools and things to actually analyze the data as well. And we invite everybody to look at this comet with us. If you're able to take your own images through like citizen science programs, we love that too. We love everybody to be sharing in the joy of NASA science as we take every opportunity to take advantage of these incredible visitors to our solar system.
And that citizen science campaign, that includes work that citizens help us do to identify small bodies in our solar system. And so if you really want to get engaged beyond just looking at the data, you can help us generate new data and find other objects for us to study.
Yep, the big one, our solar, our SOHO, big comet finder, big comet tracker. So many of those comets discovered by our citizen scientists. So keep those observations coming.
All right, we'll head back over to the phone bridge. Our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Becky. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Go ahead.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual, so that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail early on in the trajectory was part of that, an indication that the dust was being pushed off the comet on the sunward side, and then it took a while for the solar radiation pressure to push it back the other way. That's been seen before in other comets, but not very often. I'm sorry, Ken, what was the second part of the question?
Did it?
Jets. Yeah. The jets. Right. So seeing more activity in the inner coma around the nucleus, right around the time of perihelion, when it's being warmed most intensely, is something that happens frequently. That's something the comet observers are going to be very, very excited about. It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with a telescope. But people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off, additional gases can bake off, and so we do expect the composition of the comet to potentially change, or those jets to change over time. And looking at the details of what other molecules we detect beyond the carbon dioxide and water you mentioned is also going to be interesting, especially for that sort of like, what was this stuff? What was the area in this? What was this stuff made of in the area it was made like long time ago?
Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you, any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations that will be made over the coming weeks as the object comes closer to Earth?
Mm-hmm. I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are blowing off gas, they are blowing off dust, and every time something gets pushed off the comet, that acts like a little rocket engine at that moment and pushes in the other direction. And so it's very, very common to see comets have subtle changes in their orbits as a result of these little rocket forces, just called non-gravitational acceleration. So this is being monitored very closely. I spoke to our orbit determination team at the Jet Propulsion Laboratory earlier this week, and what they said is that this is being monitored. There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
In terms of future observations, this is a situation, because this is only the third time we've had an opportunity to look at an object like this. Everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off of 3I Atlas. Those are the things I'm aware of. There's probably a lot more that I'm not, because like I said, like every astronomer wants to get data on this thing because it's such a rare opportunity.
Yeah, and the high-rise image that you asked about specifically, Amit kind of rolled that out at the beginning. So please take a look at that image. I think Sean is not bragging a lot on what these astrophysics telescope. I don't know why, but because we are able to look at it in infrared with the James Webb Space Telescope, that will be the last time we can see the comet. So as it is exiting the solar system and getting further and further away, the James Webb Space Telescope will actually be able to track it longer than anyone else, partly because of its ability to kind of look long and deep rather than sort of across and wide, and the fact that it looks in the ultraviolet. So in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of tracking it to the very end. Also noted we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then as both Sean and Tom talked about, just really making sure we're sharpening up those images and really making sure they're calibrated. Right now we're putting out almost the raw images. We're putting out things quickly so everyone can see them, but we'll take some time and do some real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that as we move on to do great things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
You want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that. As Nikki said, our desire was to get these images out to the public as quickly as possible, and so there are some image artifacts in there that you'll see, and I can speak to the Lucy image that you saw previously. If you look at the comet, you'll see some blobs around the comet. Little blobs, faint blobs around the comet are not real. It came from the fact that in order to get this particular view, it was necessary, this backlit view, the team had to turn the spacecraft to face more toward the sun than it generally does. And so that means some part of the spacecraft were in the sun, and some of that bright, the sunlight reflected off parts of the spacecraft got into the camera, and that resulted in those little blobs. So that's an example of processing that has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the Soho image where we actually stacked a couple of images because a single image you wouldn't be able to see it would be too faint. But if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3I Atlas come from so far, moving as fast as it is, and not hit anything?
Orbital dynamics. And space is really, really huge, and so it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft is now 1 light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager, and Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system. But the probability of it actually hitting something is so small, because everything has to align. It's also not quite in the ecliptic plane. It's not quite in like our normal. If you think about sort of looking side on at our solar system with the sun and the planets kind of in a row, normally everything sort of orbits in this plane. This is slightly tipped, not unusual because it's not gravitationally bound to our sun, but it's slightly tipped. That makes the probability of hitting it almost even greater.
If I can play with a scale model, so if you make a scale model solar system where the sun and the Earth are 1 foot apart, that's about 1 foot. The sun is a P. The Earth, you need a magnifying glass to see. It's so small. The entire solar system will just barely fit in your hand. house if you squeeze a little bit, and the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Aquí viene otra pregunta.
Bridge, our next question is from Brandon Spector with Live Science.
Hi, I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more? And what will that tell us if it is indeed much, much older than the solar system?
I can start that, but I'm going to pass it to Sean to talk about ages in the galaxy.
Okay.
So cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution and properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3I Atlas is coming through at a speed of 60-something kilometers per second. So that's 3 times faster than the average of our local neighborhood, which is telling us that it's coming from a different population from what we have generally around us. Now, Sean will be able to clarify the age dispersion relation in our galaxy, which tells us, which has been discovered over the last century studying stars in the galaxy, that the relative speeds of stars is an indicator of age. Stars that formed older in our galaxy over time increase their random motions for reasons that Sean will explain. And so that's the circumstantial evidence that makes us think that 3I Atlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular. This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3I Atlas, what we've seen?
So because we're closer to the grains of sands on Mars, right? And so the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I Atlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3I Atlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3I Atlas, we're still 19 million miles away.
And it's going too fast for us to send something there to intercept and get that close to it. So that's just not. We just don't have the. If we could. We would, we would be there up close and getting those grains.
All right, well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow along with NASA as we continue to observe 3I Atlas. Find new images, detailed information, and resources by visiting go.nasa.
Listo, Bruno, ¿cómo? ¿Sigues por ahí?
Sí, aquí sigo, no estoy apagando aquí lo del YouTube.
¿Qué onda? ¿Tus primeras impresiones? ¿Cómo lo viste?
Wow.
Pues básicamente lo que esperaba. Se estaban explicando sobre la ciencia del C1 Atlas, el por qué se miraba distinto en ciertas fotos o tomas, porque todo tiene que ver con la perspectiva de dónde lo tomaron, pues desde el espacio o la Tierra, la luz del sol.
Antes que todo, ¿andas allá dentro del 3.1 Atlas, del 3 y Atlas? ¿De dónde? A ver, ¿desde dónde andas?
Algo más temático. Sí, aquí lo estoy viendo aquí a lo lejos, pues por eso está aquí a la luz.
Andas en una nave, ¿no? Acá de la NASA también.
¿Cuáles crees que van a ser las reacciones ahora después de esta conferencia? Porque bien, o sea, hay puntos que sí me parecen lógicos, qué bueno que se tratan, de hecho es parte de lo que comentábamos aquí con Tonka, no dejándote escuchar,
Disculpa,
cosas que a lo mejor sonarían muy básicas, pero igualmente pues, son muy necesarias. Sin embargo, creo que todavía va a quedar bastante incertidumbre en cuanto a las 12 anomalías como tal, en cuanto al tema de la aceleración. Bien, no es algo que se vaya a resolver de la noche a la mañana. Queda mucha información que van a ir constatando, que van a ir investigando. No sé tú al respecto cómo lo ves.
Pues mira, lo que siempre va a haber es especulación y siempre va a haber gente que va a esperar algo fantástico
Fantástico,
pues.
fantasioso.
Sí, claro. O sea, muchos yo creo que esperaban que dijeran como que confirmaran que sí era alienígena, que sí era un ovni o algo. Pero pues digo, los científicos pues tienen que siempre buscar basarse en la ciencia, en la evidencia científica. Pues por eso fue uno de los puntos que también hablaron ellos, de que por eso se tardaron tanto, pues porque tienen que hacer varias pruebas de peer to view para poder explicar lo que estaban viendo y encontrar un sentido, en lugar de precipitarse y dar una opinión, pues vaya
claro,
sin fundamento. Pues.
Sería mucho más irresponsable. Perdón.
Aquí lo que me parece interesante es también de que confirman que es un objeto interestelar, es un objeto que es más viejo que el mismo sistema solar, que eso también dicen ellos que es como es que tiene esta velocidad más, pues mucho más veloz que el propio sistema solar, pues. Y pues que están emocionados pues también para encontrar más información y más evidencia, más sentido a lo que es el cometa, pues porque pues tiene polvo que es más viejo que nuestro Sol, nuestra Tierra, nuestro sistema solar.
Creo que nos da una perspectiva bastante grande, pues realmente de lo poco que sabemos, de lo poco que conocemos. Sin duda va a ser un tema que va a seguir dando de mucho que hablar, independientemente de la conferencia de prensa como tal. Creo que es un tema que vale mucho la pena. Pienso que este ejercicio se va a repetir no solamente por la NASA, sino por las demás agencias espaciales. Y qué bueno, me parece que fue un ejercicio interesante. Insisto, y creo que por el morbo a lo mejor muchos hubiéramos preferido el que se viera una a una las anomalías presentadas tanto por Avi Loeb como por otros astrofísicos. Sin embargo, creo que es un buen inicio también. Creo que le baja mucho esas teorías especulativas del por qué la NASA no publicaba las fotos de manera inmediata, que también suena con bastante sentido y con bastante lógica. El primero, tener el procesamiento correcto de los datos, la verificación de que las mediciones se hayan hecho de forma correcta y sobre eso pues ya empezar a generar conclusiones y no partir al revés, no de las conclusiones empezar a generar todo lo demás.
Claro. Bueno, yo en ese sentido...
Sí, claro, y pues también digo, están mostrando, creo que mencionan de un enlace para poder ver la información pues de forma transparente.
En la propia página de
Sí, entonces invitando a la gente pues que también entre, también busquen tomar otras anomalías, pues ahí está toda la información, pues. Y que creo que al final del día, pues, quienes van a poder usar mejor esa información, pues, no somos nosotros, son los científicos. Que puedan darle más explicación lógica.
Totalmente.
Y pues bueno, pues hay que seguir viendo, porque digo, al final el cometa se está descongelando como ellos mencionan, y en cómo se está descongelando es como van a ir obteniendo más información de qué está compuesto del polvo interestelar que mencionan. Hay muchas cosas que están interesantes.
Sí, bastante. A mí me emociona mucho, lo he venido, ya parezco disco rayado, no lo he comentado desde el primer video en el que hablamos de este fenómeno. A mí me emociona el hecho de que estemos volteando a ver hacia el cielo, me emociona el hecho de tener un cuerpo celeste, un cuerpo cósmico que es más antiguo que el sistema solar, y todo lo que genera alrededor me parece fascinante. Ojalá que sea el comienzo para que muchos gobiernos comiencen a darle mucha más atención a la ciencia, que volteemos al tema de la investigación, también que no todas las noticias sean guerra, sean conflictos de todo tipo o escándalos de la clase política, sino que también hay bastantes noticias en torno a la ciencia y quizá pues es una oportunidad de voltear a ver para allá.
Sí, claro, totalmente de acuerdo.
Perfecto, pues para...
Yo quería comentar algo, nada más de lo último que estaban diciendo respecto a cómo el asunto de no soltar, digamos, la información o no dar, digamos, las imágenes así tal cual, es porque también yo creo que tenemos ya esta idea medio torcida, yo lo quiero decir así, o sea, en la sociedad de que todo debe ser democrático, mientras que también hay muchas cuestiones, o sea, que la ciencia no puede, digamos, lo voy a decir, aunque suene mal, pero no lo puede como democratizar, vamos a decirlo así. Primero va a pasar, digamos, por una observación de quién, de quiénes son los expertos en ese tema. La mayoría de la gente, o sea, como, vamos a decirlo así, ¿no? Y estoy exagerando, pues, pero mucha gente podría ver esas imágenes y decir, y encontrar esto, ¿no? Como tú dices, ¿por qué? Porque ya a priori ya vienen concepciones,
pasó,
ideas.
Y ya pasó, ¿no? O sea, muchas de las imágenes
Sí.
que se dieron del 3 y atrás,
Sí.
dijeron, no, es que son 6 naves. Oye,
¿De
dónde sacas eso, no?
Ajá,
No, pues que yo interpreto que esto es A, esto es B, esto es... Pero pues, a lo mejor no dudo de la buena intención, pero pues no somos las personas correctas para hacer una interpretación de una imagen de ese tipo.
Así es.
O luego, algo que yo escuché mucho, sobre todo en las imágenes primeras que se dieron, era, no, pues que ¿por qué se ve todo de esa tan mal, teniendo tanta... A ver, es que no son fotografías como la que tú te tomas de selfie.
Claro
Lo que
no,
se está midiendo
pues,
son
claro.
la luz, los espectros, o sea, es distinta la forma de analizar y observar dichas imágenes.
Exacto. Y eso es a lo que yo me refiero, pues, o sea, que justamente como son expertos los que están ahí, pues, digamos, para hacer eso, no cualquiera va a tener, digamos, el criterio para analizarlo de esa manera. Bueno, ese es mi punto, pues, o sea, también al respecto. Está bien, de alguna forma también que esté la información y que se vaya dando poco a poco, eso también estoy de acuerdo. Yo creo que también tenía mucho que ver, y esto ni modo lo quiero mencionar, el hecho de que ya había mucha como especulación al respecto y que se empezaron así los rumores de que es una nave extraterrestre, es un objeto artificial. Entonces ya como tú bien lo has dicho, yo también parezco disco rayado, la gente ya empezó a priori a ponerle esos elementos al cometa. Y digo, bueno, igual, o sea, también es otra cosa. Yo creo que también es como esperamos eso, ¿no? O sea, esperamos el gran anuncio, ¿no? De que ya llegaron los...
Totalmente. Sí.
Y queremos de alguna forma como forzar eso. Pero no, pues, o sea, también ahorita ya pues, nos van dando otras conclusiones.
No, y ahora, el ejercicio me pareció interesante, me pareció bonito, me pareció agradable el hecho de tener a científicos como panelistas, que fuera esta pregunta y respuesta por teléfono, tomar algunas preguntas de redes sociales. Creo que le va a bajar un poco a estas especulaciones, no tanto sobre el objeto, sino más bien sobre un supuesto ocultamiento de información y todo ese tipo de teorías que siempre suelen salir y acompañar este tipo de fenómenos. Ojalá que no sea el último ejercicio de esto por parte de la NASA, sino que esto realmente
que se vuelva constante.
Exacto, que nos empecemos a acostumbrar, vaya, a tener ese tipo de comunicación, ese tipo de contacto con las autoridades, con la academia, no solamente con las instituciones públicas. Y pues bueno, ojalá que sirva como invitación pues, para que más personas se acerquen al tema de la astronomía. Bruno, no sé si tengas alguna última conclusión antes de cerrar la transmisión.
No, ninguna conclusión. Solamente hay que esperar. Hay que esperar nada más. ¿Sí? Yo creo que es el comienzo de lo que viene. Entonces hay que esperar. Digo, no podemos precipitarnos a algo fantástico todavía. Hay que siempre tratar de mantener una perspectiva pues, más basada en ciencia. Y claro, pues también considerar la parte fantástica, pero a un lado, ¿no?
Sí,
No,
más
no
como un tema
tampoco.
de braille, de imaginación, de poder
Sí,
jugar a imaginar los supuestos, no a tomarlos como una realidad per se, al menos no hasta que haya elementos suficientes que pudiesen comprobar algo de ese tipo. Sin embargo, el ejercicio de imaginar siempre es bellísimo mientras lo tengamos entendido que es solamente eso.
así es.
Oye, pues a ver si la otra semana ya grabando del otro lado, pues ahora ver también por ahí el tema de Epstein, que ya es una votación sumamente interesante, que ya se
Muy
van
divertida.
sí, que ya se van a revelar por ahí los documentos, aparentemente sin censura. Obviamente hay una serie de especulaciones al respecto. También hubo ayer un acuerdo con el príncipe heredero de Arabia Saudita. Por ahí una reportera de ABC hace preguntas sumamente interesantes, sumamente inteligentes, una respuesta burda como acostumbra Donald Trump, sobre todo por el tema de este presunto asesinato, bueno, no presunto, de este asesinato, pero por presunta autoría del príncipe heredero de un periodista en la embajada de Turquía, a lo cual obviamente pues, Trump responde de manera molesta y enojado, y pues muchos
Claro.
temas en Estados Unidos, ¿no? Ha estado muy, muy movido. El tema de Epstein sin duda puede ser la apertura a muchas otras cosas, ya sea para distraer, ya sea para cambiar de tema o simplemente por la naturaleza del mismo. Pues bien, Bruno, agradecerte como siempre, Tonka. Muchas gracias por acompañarnos y a todos los que nos ven. Espero que les haya gustado este video. Si es así, deja tu comentario, tu like y suscríbete al canal.
Hasta luego.